Hello everyone, and welcome to our lesson on 9.3. This is part 1 about special right triangles. So we've been learning all about right triangles. Of course, right triangles contain a right angle, and we learned about the Pythagorean theorem, and now we're going to learn about a special type of right triangles. That special type today is our 45, 45, 90 triangle. So when it says 45, 45, and 90, of course it's referring to the angles in the right triangle. We have a 45-degree angle present here, one here as well, and then this one as well. That is a 90-degree angle, 45, 45, 90. Okay? Even if you only had one 45, let's say in this picture all that was there was the 90 and the 45, we could use the triangle angle sum theorem to do 180 minus 90 minus 45, and that would force this angle to be 45 as well. Okay? So the first thing we talked about in class is we looked at an example of a problem where the legs matched, and we talked about how that meant that those base angles matched as well. And so we're going to kind of do the opposite of that here. If both of these angles are 45 degrees, these two, that means that these legs are going to match. This length is going to match this length. Okay, so I'm going to actually recolor code that. Let's do that in blue. This leg, I'm going to name that. This leg, L-E-G, is going to be the same length as this leg. Okay, the legs are going to be congruent to each other. So then it says that the hypotenuse, which we know is the side that is opposite that right angle, that's this side right here, is going to be that leg times the square root of 2. So let's do that in color. Leg times the square root of 2. That's going to be a relationship. So if I did that in variables, oftentimes they'll have it written out like with a formula. If this is x, then this side length is x as well. And so the hypotenuse is going to be x times the square root of 2. Okay, let's think through that a little bit. So I like to kind of map this out for students. If you are going from x, from a leg, okay, so I'm going to color code this. Let's go to yellow. If I'm going from one of these legs, we know that they match. If I'm going from one of these legs to the hypotenuse, I'm going to be getting bigger from a leg to a hypotenuse. So you're going to multiply by the square root of 2. To go the other way from a hypotenuse back to a leg, the inverse of multiplying by the square root of 2 is dividing by the square root of 2. So every time I'm going to be using a root 2, if it's getting bigger, you multiply by root 2. If it's getting smaller, you divide by root 2. I did want to mention that this actually can be, one of these triangles can be formed by drawing the diagonal of a square. So let's draw that out. If we have a square, we know the square has 4 congruent sides, and it's got 4 right angles. When you draw in the diagonals of one of these squares, 90 divided by 2 gives me a 45, 45, 90 triangle on each side of this diagonal. So 2 congruent 45, 45, 90 triangles. So this relationship will be true as well. X, X, X root 2, or leg, leg, leg root 2. So that's where it will pop up most often. And you can tell, looking at these problems, all of these look like these are a portion of a square that has been sliced down the diagonal, which they are. So it says, in the first set of directions, solve for the unknown values in the special right triangle, each one. So the first thing I'm going to do is color code. Here's my right angle. So here are my legs, and then here's my hypotenuse. So what am I given? What information am I given? I'm given one of the legs is 10. So I also know that the other leg is going to be 10. So y is going to be 10. Both of those are going to be 10. To get to the hypotenuse, which is x, I'm getting bigger. And I'm going to take that leg and I'm going to multiply by the square root of 2. So that's going to be 10 times the square root of 2. What is 10 times the square root of 2? Well, when you simplify that, that is just going to be 10 root 2. 10 root 2 is what your hypotenuse is. So leg, leg, leg root 2. Okay. All right. What do we have in our next triangle? Let's start by color coding. Here's my hypotenuse, and here are my legs. So I'm missing both of my legs. But I do have my hypotenuse. What is the hypotenuse? 4 root 2. So if I want to go to the leg, that's getting smaller, so I'm going to divide 4 root 2, the hypotenuse, by root 2. What happens when you do that? You get to cancel out these root 2's because it's in the numerator and the denominator. So that simplifies to whole number 4 for x, which is also going to be y. So 4, 4, 4 root 2. Both of these legs have a length of 4. Because if it's a 45, 45, 90 triangle, the legs are congruent, so they are both 4. Okay, let's go to our next two problems. Here are my legs, color coding. I'll go ahead and do that to this one as well. Here is my hypotenuse. I am given a leg. One of my legs is root 6, so the other leg is also going to be root 6, so let's fill that in. It's also going to be root 6. So y is root 6. How do I get to my hypotenuse? Going from a leg to the hypotenuse, you're getting bigger. So you're going to take that root 6, and you're going to multiply that root 6 by the square root of 2. It's the leg times the square root of 2. Well, root 6 times root 2 is root 12. That would be our final answer if it didn't contain a perfect square besides 1. But it does. We can rewrite the square root of 12 as root 4, root 3. What is the square root of 4? 2. So my hypotenuse is going to be 2 root 3. My final answer will be 2 root 3 for my hypotenuse. Okay. This last problem on this row, I have a whole number for my hypotenuse this time. And so what we're going to do is we're going to work backwards to find a leg. So how do you go from the hypotenuse to the leg? I'm going to divide by the square root of 2. So I'm going to take the hypotenuse and divide by root 2. Unfortunately, this leaves a radical in the denominator, which means that it's not fully simplified. So we're going to have to rationalize this denominator by multiplying it by a value root 2. That would turn this into a perfect square, which is root 4. Square root of 4 is 2. So let's see what happens in the numerator. That's 12 root 2. So 12 root 2 over 2, I can simplify that fraction, that 12 over 2, to be 6. 12 divided by 2 is going to give me 6. And so that is going to be 6 root 2 for the leg. So if this leg is 6 root 2, then this leg is also going to be 6 root 2. So both of my legs have a value of 6 root 2. After we did a few of these problems in class, a few of you have picked up on the fact that if the hypotenuse is a whole number, so that you can tell this is a whole number, 12, then every single time what's going to happen is if you take that whole number and divide by 2 in a 45, 45, 90 triangle, the legs are going to be 6 root 2, which is half. And so if you do half of the hypotenuse and then you multiply it by root 2, that's what each of the legs are going to be. So many of you, when we got to this next problem on this bottom right, next on this row, noticed that that same pattern was happening. So if this was 20, you would divide by root 2 and divide by root 2. Whenever you do that with that whole number, that ends up making both of these 10. Half of 20 is 10, so 10 root 2 and 10 root 2. But if you didn't understand that process, again, you would just do 20. We're getting smaller, so we divide by root 2. Then you have to rationalize the denominator, so we do that in the numerator and in the denominator. We multiply by root 2. That would be 20 root 2 over root 4. That is 20 root 2 over 2. And then 20 over 2 simplifies to 10 root 2. So that's how you would do it using the actual math, but many of you noticed that pattern. We call it the party trick, just to make it go a little bit faster. All right, let's do this problem. Where's my hypotenuse? It's here. Here's both of my legs. So if one of those legs is 12, the other leg is going to be 12 as well. Okay, and so what does that make the hypotenuse? I'm going from a leg to the hypotenuse, so I'm going to multiply by root 2. So that's going to be 12 times root 2, which is just root 2. So 12 root 2 is my hypotenuse, and then 12 was the other leg. Okay. Here is a problem where you have 6 root 2 as your hypotenuse. So what happens when you go to a leg? We're getting smaller, so we're going to divide by the square root of 2. So we're going to take 6 root 2, and we're going to divide by root 2. Those root 2's cancel out, and then both of those legs have a value of 6. Both of the legs are 6, and the hypotenuse is 6 root 2. So which fits our script, leg, leg, leg root 2, as well as that problem right there. This is the last one on this row, and it seems tricky because it does have a radical in the leg, but we're just going to copy it over just like normal. The x is also going to be 3 root 2 because both of those legs are going to be congruent. And so when we go to our hypotenuse, we are getting bigger. And so I'm going to multiply by the square root of 2. So I'm going to take the leg, which is 3 root 2, and I'm going to multiply that leg, 3 root 2, by root 2. That is going to give me 3 root 4. Square root of 4 is a perfect square. That's just 2. So then 3 times 2 gives me 6. So the hypotenuse is 6, and the other leg is 3 root 2. Our final hypotenuse is 6. So that fits our script from earlier, what we called the party trick. If the hypotenuse is 6, then both of the legs are half of that root 2. Okay. Last questions have our sentences or word problems about squares. And so we don't have a picture, so if in doubt, you can always draw it out. It says a square, so let's draw a square. 4 congruent sides, 4 right angles, and that square has a diagonal, it says, of 13 root 2. So I can draw in my diagonal either way, but I'm going to go from a vertex to a vertex, and it has a diagonal of 13 root 2. what is the length of the side of each room, which is this piece. And so what we have is a hypotenuse, which is that diagonal, and we know that this is a 45, 45, 90 triangle because it's the diagonal of a square, which splits into a 45, 45, 90 triangle. And so if the diagonal is 13, to get to the side length, I'm going to do 13 root 2. Oh gosh, that was a horrible 2. 13 root 2 divided by root 2. Those root 2's cancel out, and then 13 is my side length of the square. All right, here we go. A square, so draw a square. Here we go. Says that it has a perimeter, so not a side length, not a diagonal, but a perimeter, which is all the way around the outside, of 20 root 7. It wants you to go through, if it has a perimeter of 20 root 7, and find one of the actual diagonal lengths of the square. So that is going to be the hypotenuse. So if I know the side length of the square, then I can find the diagonal of the square, but I don't know the side length yet. So I'm going to have to use the perimeter in order to do that. So how do I find a side length? That side length is going to be equal to the perimeter, which is 4 of the sides, divided by 4. So 20 root 7 divided by 4, each of those 4 sides. Okay, because each of those sides is going to be the same length. So I'm going to divide that by 4. So what is 20 divided by 4? That is going to give me a side length of 5 root 7. 20 divided by 4 simplifies to 5 root 7. So each of these sides in the square is 5 root 7. That's a 45, 45, 90 triangle. And so if the side lengths are 5 root 7, the hypotenuse, or the diagonal, is going to be 5 root 7 times root 2. And then 5 root 7 times root 2 simplifies to 5 root 14. And there are no perfect square factors that go into 14 besides 1. 9 does not work, 4 is not a factor, and so 14 times 1, that's my only perfect square, and so that just means it's fully simplified. All right, your homework is that back page. Again, those have got some word problems at the bottom. You can draw some pictures for those, and we will check that tomorrow in class.